Well, hello guys, here Mr. Yu with another video, and as promised we're going to be doing a question on isotopes and relative atomic mass, etc. So it's an important video. I'm going to leave the question in the description below so you can actually answer before watching the video. But before we go on, don't forget to subscribe for the channel and like the video so you can get all the notifications and videos I post on regular basis. This question was done in the Eastern Cape in 2022. The question says an element X has two isotopes. The percentage abundance and atomic masses are given below. Define the term isotope, and for sure it's going to be in the exam guide. So what you have to say that isotopes are atoms from the same element with the same atomic number but different atomic mass. In other words, they will have the same of protons but different number of neutrons. And if you say this one, same number of protons but different number of neutrons, you'll get the mark as well. It's the same. Okay, now for question 3.1.2, calculate the relative atomic mass of element X. All this one can be done in one equation and it's quite simple. So what we are going to do, we are going to multiply the percentage abundance times the atomic mass. For example, we're going to say 60,4 times 69,52. Let me do it here. 60,4 times 69,5252, and we're going to add the other one, which is 39,6 times 70,929. There we go, and everything will be divided by 100. That is a way of doing this. One is question 3.1.2. Okay, and if you do that, you will get that it's 70,08. That is the answer here. Okay, now if you do that, you will get 1 mark for this substitution here, 1 for this substitution, and 1 for the final answer. It's quite simple. Now alternatively, you can then do it separated, like you multiply 60 times 69,5252 divided by 100, and you multiply 39,6 times 70,924 divided by 100, you get answers, and then you add the 241,99 plus 28,009, and you will get 70,08. This is option 2. So you can do alternatively either one. So it's up to you entirely which one you prefer. Write down the symbol of element X. Now, to get element X, we have to go to the periodic table and look for 70,08 as a mass. So if you come to the periodic table, you are looking for 70,08. There is no such one here, but the closest one is 70. So the element is gallium, is Ga. That is the element they want. And if you write that, Ga, you'll get 1 mark. There's 1 mark for saying Ga. Question 3.2. The number of protons and electrons, the mass, number, and the atomic mass of aluminium and its ion are shown in the table below. Some of these values in the table have been omitted. Write down the letters AE on the answer book and next to each other the number omitted. In other words, we have to complete the table. So let's go starting with aluminium. Aluminium is neutral. As you can see it here, is neutral. It doesn't have charge. This one is not neutral. This one is positive. Okay, that is important. The first one is neutral. The second one is positive. So it is neutral. You need to remember that we'll have same number. Let's fix that. What is that? Same number of electrons and protons. I'm going to write electrons and protons like this. If you follow me, you can understand what I'm saying here. So because it have the same number of electrons and protons is neutral, that means that this one will also be 13 electrons. Now the mass number is 27, atomic number And the atomic number, guys, the atomic number is the same as the number of protons, so it will be 13. So that is the first one. Number of electrons is the same because it's neutral. Atomic mass is 27, they're giving you that one, and the atomic number and the number of proton is the same. Okay, now for Al, the number of protons do not change. The number of proton cannot change here. It's the same. So this one is also going to be 13. Even though it is an ion, the only thing that changes is the number of electrons. Okay, so that is important, as well as the mass number. The mass number doesn't change. So if it was 27 at the beginning, it's also going to be 27 here. It doesn't change. Now the only thing that changes here is the number of electrons. Now I want you to see something. It is a positive ion. It is a positive charge. Why is positive? Because it lost electron. So it definitely will have less electron than 13. It must be a number less than 30. But I want you to look at D3. D3 means it has lost 3 electrons. So it lost, I'm going to write here, 3 electrons. It did have 13 at the beginning and it gave away, or it lost 3 electrons. It means that now we'll have 10 electrons. And it's quite simple, guys. Nothing to say here. It's 1 mark per cell here. So you will get 1 mark for saying the 13, 13, 13, 10, and 27. It's quite simple. I hope you understand. It's very, very easy. Question 3.3. The SP notation of an unknown element X is shown below. Now, for this unknown element, what we know then? We know that it will have 18 electrons. 18 electrons. These 18 electrons is coming for these little numbers on top. I add, and that gives me the number of electrons there. Okay, so if we go to the periodic table, we actually are talking about argon, which have 18 electrons. Okay, so this unknown element is going to be argon. This one is not the question yet. We're just trying to save some time. So this element is argon. Now we're going to answer the question. For element X, write down the number of valence electrons. Now what I want you to recall, valence electrons in the last energy level. Okay, the last energy level here is energy level 3. That is the last energy level. So you have 2 electrons in 3s and 6 electrons in 3p. Therefore, the total valence electron that we have here is going to be 8 electrons. That is the answer there. And if you do that, you will get 1 mark. Determine the period with the element is found on the periodic table. Now I show you is argon, guys. And argon is in period 3, group 18. So the period is going to be period 3. So period 3. And if you say period 3, let's write it with word. If you determine the period, you will get 1 mark. Highest energy level in which electrons occur. And we already spoke about that one. The higher energy level is energy level 3. So is energy level 3. Let's write here, let's erase this one and write level 3. Okay, and if you say that, you get 1 mark. There is 1 mark for that. And the final one is the symbol, which we already determined which one is the element, is argon. So the answer is AR, that is the symbol, and there is 1 mark for that. Okay, so let's go to the next one. Write down the type of bond that form between chlorine and aluminium. Important here. Very, very important. We have a combination between a non-metal and a metal. Guys, that one will give you, or will give us, an ionic bond. Ionic bond. You have to remember that. If you have a combination of a non-metal, this one here is non-metal, right? And this one is a metal. It will give us an ionic bonding. And if you say that, you will get 1 mark. Question 3.5. Draw the Aufbau diagram for chlorine ion. Now they're speaking again about ion. Alright? Now, if we go to chlorine in the periodic table, we can see that we have 17 electrons. That is a normal chlorine. So, normal chlorine will have 17 electrons. Okay? Cl will have 17 electrons. But Cl minus means that it has gained electron. How many? 1 electron. So, Cl minus will have 18 electrons. Right? No 17 anymore. And we have to draw the Aufbau diagram. So how we are going to do this one? This one is question 3.5. Okay? So for Aufbau diagram, you have to start with a 1s. And 1s, you are going to have a circle. Okay? In that circle, you are going to place 2 electrons. So for example, 1 and 2. We still have more to go, so we'll go to 2s. Now in the second energy level, we'll have 2s, which is another circle, and we'll have 2p, we have 3 circles. Remember, in each circle, you can only place 2 electrons. And now how it works as from here. You are going to do the following. 2, 3, and 4. We still have more electrons to go, so we go to the next energy level to 2p. So it's 4, 5, 6, and 7. Alright, we still need more. We need, remember, 17. So we go back and say 8, 9, and 10. And we go to the next energy level. Now we go to 3s, which is another circle. There we go. And we're going to 3p, which is 3 circles, 3 orbitals there. Okay, same story. So we have, let's recount, 2, 4, 6, 8, and 10. Right? 10, 11, and 12. 13, 14, 15, 16, 17, and 18. And guys, this one is the electron configuration, the Aufbau diagram for this specific atom, or ion. In this case is hydrogen chlorine ion. So this one is for chlorine ion. Okay? Now the marks allocation here, guys, you will get 1 mark for completing this side here, 1 mark for completing this side here, and 1 mark for completing the last part there. Okay? Now, to finish the question, draw a Lewis dot diagram to show the bond formation between aluminum and chlorine. So now, this one could be a little bit tricky, and it's very important. So 3.6. First of all, we are going to draw the Lewis dot diagram for each of them individually. Okay, so we remember aluminum have 3 valence electrons. Let's go to the periodic table. Now here we are. The valence electrons are going to be given by these Roman numbers to you for what you work. This will give you the valence. Alright, so all elements here will have 1 valence, 2, 3, 4, 5, 6, 7, and 8. In other words, aluminum is here, it will therefore have 3 valence. And in the Lewis dot diagram, you only represent the valence. The other one is chlorine is here, it has 7 valence electrons, okay? So we're back here. Aluminum have 3. 1, 2, and 3. We always do it like that. Let's do aluminum individual. Sorry, chlorine. Aluminum is already done. Chlorine have 1, 2, 3, 4, 5, 6, and 7. That is chlorine. Alright? So now what we notice, we can give 1 from aluminum to chlorine. Alright? But we still have 2 left from aluminum. So we have to need, we're going to need 3 chlorines in actual fact. So if you do this one now completely, we are going to have aluminum with the 3 valence electrons. There we go. Plus chlorine. Plus chlorine. Right? Let's do it again. There we go. Now what is going to happen, and this one does not need to be represented, that one of these will move there. Alright? But we still have 2 left. That's why we need actually 3 chlorines. So the best way to do this one is to write here a 3 at the front. We have 1 aluminum, but we need 3 chlorines. Otherwise, you'll have to draw 3 chlorines individual there. Okay? So what will you have at the end? You will have aluminum with a 3 plus, because it gave away all these electrons we were speaking about. All of them are gone. Okay, so let's do it here with all the chlorine. So now this is what we actually have, but we don't have to represent the too many chlorines. We don't have to represent each of them. So what is going to happen, instead of writing or drawing 3 chlorines, you do the 3 at the front here. This one is a Al. Let's fix it here. It's a L there. Now what is going to happen, guys? Aluminum will give one of these electrons, will give it there, the other one will give it there, and the other one will give it there. You can see there is an empty space. There is an empty space here for that specific electron to come. All right, so what are we going to have on the other side? Aluminum is Al. Let's fix this one here on top. It's Al without valence electrons, and therefore we write 3 plus because it gave 3 electrons. That is the meaning of that 3 plus. Let's move it a little bit to the left, sorry, so it can actually fit the other one. Sorry, here let's move this one to the left, and as well as this one, let's move it a little bit to the left. There we go. But now what do we have? We have 3 chlorines, which each of them will have an extra electron. So actually we are going to have a chlorine with 1, 2, 3, 4, 5, 6, 7, and the extra one, I'm going to use a different color, an extra one that is coming from the aluminum. All right, this one here, all this one here, because of that extra electrons, is going to be negative. And how many of them we have? We have 3. 1, 2, and 3. So it's 3 chlorine. Guys, this one is the drawing. The same happened here. Now this one is the better way to do. I'm going to do it now fully because you understand already. And this one is how we represent this one. This one is the ionic bonding for the formation of aluminum chloride. I hope you understand. It's quite important. It is for sure going to be in the exam, so please don't mess this one and try to do it by yourself. Thank you for watching. This one is the end of the question. Don't miss next time. Next time we're going to be working with more about the periodic table. It could be quite tricky, but for now it's all. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.